We have locked the moon. There's a far side of the moon, there's a near side of the moon.
For over half a century since our last moon mission, we've explored the vastness of the solar system, uncovering new celestial secrets. Yet one profound mystery remained close to home. Our moon, it seems, has two distinct faces, the one we see and another concealed in shadows. Why are they so different? For years, this was a riddle no one could solve. But now, NASA's astrophysicists claim to have the answer. But that's not all. There's a growing anomaly on the moon that NASA is closely monitoring. Could our familiar satellite hide a danger to Earth? Join us as we realize that even the most familiar things can turn out to be completely different from how we perceived them, and prepare to witness insights that have remained untold in any ever before. As NASA prepares to embark on a lunar journey once again by 2024, scientists emphasize that our closest celestial neighbor, the moon, still holds many secrets waiting to be unveiled. Despite its proximity, being just 250,000 kilometers away from our life-sustaining atmosphere, the moon remains an enigma. For eons, humans have looked up, captivated by its mesmerizing glow, deciphering familiar patterns and weaving enchanting stories to make sense of its mystique. However, our age-old fascination took a dramatic turn just 6 decades ago. The Soviet Luna 3 probe changed our perspective forever by capturing the hidden face of the moon. In ancient Eastern traditions, when we think of the moon, the image of a jade rabbit is conjured, meticulously pounding the life-giving elixir. It weaves medicines and prepares ingredients for the cherished rice cakes. Meanwhile, in the contemporary West, tales of a man residing on the moon still enchant children, lulling them to sleep. But there's another facet of the moon, often misnamed as the dark side. The side that constantly faces Earth is known as the near side of the moon. This is the side we're most familiar with, the one that's been gazed upon by countless generations. Bright, luminous plains called Maria dominate the landscape, formed by ancient volcanic eruptions. They contrast sharply with the craggy, rugged highlands, creating a visual spectacle that has inspired countless myths, legends, and stories. The near side also hosts the moon's largest and deepest impact crater, the Aitken Basin. Mysteriously, this side of the moon also has a stronger magnetic field than its counterpart. Now, let's venture to the far side, the side permanently hidden from Earth's view. Often called the dark side, though it receives as much sunlight as the near side, it remained a mystery until 1959 when the Soviet Luna 3 mission sent back the first images. And what they revealed left them astounded. A vastly different landscape. This side is saturated with countless craters, giving it a rough and battered appearance. Unlike the near side with its vast Maria, the far side has only a few. The terrain here is filled with mountains, some rising over 10,000 feet high. The reasons for such stark differences between the two sides remain one of the moon's greatest enigmas. But perhaps the most intriguing aspect of the far side is its silence. Since it's shielded from Earth's radio waves, it's considered the quietest place in our solar system. This eerie silence has led to various speculations. Some believe that if there were extraterrestrial bases or ancient artifacts, they would most likely be on this side, hidden from our view and prying eyes. But why are these both sides so dissimilar? Although scientists are still scratching their heads on this one, a recent study seems to have attempted to form a plausible explanation for this absurd dilemma. If you've ever gazed up at the moon and wondered about the wavy hues, you're not alone. These patterns, known as lunar mare, are not just random designs, but are made up of ancient lava from the moon's surface volcanoes. But here's where the mystery deepens. Why does the far side of the moon lack these traces? If one side of the moon has evidence of volcanic history, shouldn't the other side bear the same marks? This perplexing question caught the attention of a research team dedicated to uncovering the moon's secrets. Using advanced computer simulations, these scientists delved into the moon's past, long before any volcanic activity began to mold its surface. They recreated the massive impact that altered the moon's surface billions of years ago, leading to the formation of the giant crater known as the South Pole Aitken Spa Basin. Matt Jones, a planetary scientist at Brown University and the study's lead author, shared an intriguing observation. We know that big impacts, like the one that formed SBA, would create a lot of heat. The real mystery lies in how that heat impacts the mechanics of the moon's interior. As they unraveled this enigma, they found that this colossal collision would have produced a plume of heat, transporting certain chemical components to the near side of the moon, while mysteriously sparing the far side. This plume of heat is believed to have played a crucial role in the moon's appearance. The heat potentially contributed to the melting of the mantle, leading to the lava flows that are now visible on the moon's surface. So, those captivating patterns that we see when we look up at the moon might be the remnants of a fiery past. This elusive side of the moon also arises from its initial mystical interaction with our Earth. Picture this: Buzz Aldrin and Neil Armstrong aboard the Apollo 11 lunar module, charting their path to the moon. After an intense 3-day journey from our blue planet, the sight that greets them is mesmerizing. Deep, enigmatic craters, massive boulders scattering the unfamiliar terrain, and a veil of fine dust that dances around their spacecraft. As the lander made its descent onto the moon's surface, Aldrin and Armstrong were met with an unexpected sight. The ground appeared to be moving upwards, but in reality, their spacecraft was sinking, reminiscent of a stone swallowed by quicksand. The thick layer of moon dust was pulling their 15-ton lunar module beneath its surface. Panic set in. Would they ever be able to leave the moon? While the Apollo 11 mission's primary goal wasn't solely lunar research, it paved the way for deeper cosmic understanding. The subsequent 6 missions, coupled with the earlier robotic ventures, unlocked the moon's secrets. Over 2,000 moon rocks, collected by brave Apollo astronauts, revealed insights into the moon's age, makeup, and origin. Yet, when the last human footprint was left on its surface in 1972, and the final Soviet lander bid its goodbye, many mysteries remained. Decades passed, and even with Apollo's groundbreaking discoveries, enigmatic questions about the moon lingered, beckoning us to explore further. In 1993, a robot last touched the moon, sent by Japan. But the late 2000s saw a renewed interest in lunar exploration, spearheaded by giants like NASA, China, India, and Japan. Over a decade, 14 missions from these space powerhouses successfully reached the moon. China even achieved a historic feat by sending a rover to the moon's elusive far side. Now, as NASA prepares to send humans to the moon's south pole, lunar enthusiasts have never had more to be excited about. This recent surge in lunar exploration has opened up a treasure trove of opportunities for planetary scientists eager to decode the enigma of this rocky satellite. There's one burning question that keeps them up at night. Why aren't the moon rocks as old as the moon itself? Imagine this. The moon is a staggering 4.5 billion years old, just a mere 60 million years younger than the entire solar system. During the tumultuous times when our sun was still in its infancy, the early solar system was a chaotic mixture of solid objects colliding and swirling. This chaotic process, known as planetary accretion, led to the formation of bigger and bigger entities. It's fascinating to think of the moon being formed during this cosmic maelstrom. But here's where it gets even more mysterious. The brave Apollo astronauts who ventured to the moon brought back with them a collection of rocks. An analysis of these rocks revealed something astonishing. Most of these rocks were formed about 3.9 billion years ago due to impact events. However, there's a puzzling gap. Almost none of the rocks can be traced back to the moon's initial 600 million years. Now, isn't that curious? If the moon was a result of frequent collisions, shouldn't there be more rocks from its early days? Why is there a significant absence of rocks from the period when the planetary accretion process was in full swing? This lunar riddle is just one of the many that scientists are eager to solve, and some suggest that they might have done just that. This is what they propose. In a time long past, around 3.9 billion years ago, the moon faced what can only be described as an apocalypse. This era, known as the Late Heavy Bombardment, or more dramatically, the Lunar Apocalypse, saw the moon besieged by countless impacts. But why? What caused this celestial onslaught? The research of the scientists seems to suggest that during this chaotic time, the outer planets, which were once cozied up closer to the sun, began to drift away. As they journeyed outwards, they sent a barrage of large pebbles crashing towards the moon. But like every theory, there's another side. Some argue that this great deluge never happened, and that we've been misled by the Apollo moon rocks, which show an abundance of impacts from around 3.9 billion years ago. Among these rocks, 3 impact craters stand out: Imbrium, Serenitatis, and Nectaris. These craters, sampled by the final Apollo missions, hold the secrets of our moon's mysterious past. However, new data has emerged, presenting a twist in our story. It is reckoned that the materials we've used to date these craters are merely remnants from the impact that birthed the grand crater Imbrium 3.9 billion years ago. So, which one of the theories is correct? How can we objectively describe the phenomenon using empirical data? Venturing into the moon's hidden corners, like crater on its remote side or the shadowy South Pole, could unravel the mystery of the lunar cataclysm controversy. These untouched areas hold samples unaffected by past impacts. What if these samples reveal secrets older than 3.9 billion years? Such discoveries would challenge everything we know about the lunar cataclysm and shed light on the enigmatic events of the early solar system. But this is just scratching the surface of the anomaly that we call our moon. One of the most striking questions that has fascinated scientists for decades is this: where did lunar water come from? Almost 40 years after the Apollo 15 mission left the moon, a startling discovery was made in 2009. Water, the elixir of life, was found inside rock samples brought back from the moon. This finding hinted at the thrilling possibility that the moon might have housed water since its very formation. This revelation has not only blown our minds, but has also ushered in a new era of lunar research. Using data from India's Chandrayaan-1 mission, NASA scientists have now confirmed the existence of water ice, predominantly near the lunar South Pole. These hidden pockets of ice, nestled in permanently shadowed craters, remain at chilling temperatures of -250 degrees Fahrenheit. But the question is, where did it come from? Was it present as large frozen blocks, or tiny crystals blended with the moon dust? Paul Hayne, a renowned planetary scientist at the University of Colorado Boulder, sheds some light on this enigma. 3 intriguing theories emerge. The first suggests that water ice arrived from outer space, hitching a ride on asteroids and comets. As these celestial objects crashed into the moon, the water melted and eventually journeyed to the poles. Another theory paints a picture of the moon's surface changing in temperature. Here, charged hydrogen from the sun's powerful winds meets with oxygen lurking in the moon dust, resulting in a dramatic escape of water vapor. But the most enchanting theory of all is that water might have been a part of the moon's very essence. Imagine this: the initial material that birthed the moon held water. Over time, fiery volcanic eruptions forced this water to the surface, revealing its presence. Some scientists conjecture even more and posit that all 3 of these processes might be at play at the same time, each working on its own, potentially contributing to the water formation on its surface. If that theory is correct, another question seems to enter into the fray: which method produced the most water? Sadly, Hayne claims that while theories abound, concrete evidence remains elusive. Interestingly, however, some light was shed on this mystery in 2009 when NASA launched the Lunar Crater Observation and Sensing Satellite aimed at the South Pole. Not only did it find water, but also traces of components typical to comets. This hints that perhaps asteroids played courier, delivering some of the water to the moon's surface. But to unravel this enigma, Hayne believes it's crucial to take a step further. Whether by robot or human, a sample must be collected and analyzed. Only by delving deep into its isotopic composition can we truly understand if the moon's water was a gift from comets, asteroids, or simply the whisper of solar winds. The path to answers may be within reach, but until then, the moon's watery tales remain a captivating mystery. The enigma of how lunar water became concentrated at the poles remains unsolved, Hayne points out that even if we uncover the origin of this liquid on the moon, another mystery looms large. Does the water vaporized from comet and asteroid impacts drift across the moon's surface, or does it remain trapped in the regolith? The lunar science community is torn over this question. The only way to unveil the truth seems to continue the rigorous testing. But just like every other thing in the universe, there's always more to explore and more to understand. In this cosmic spectrum, a single thing can help us trace to a plethora of other things. Some scientists believe that the moon can give us a cursory glimpse of the infant years of our entire solar system. As the moon's ancient surface has remained more or less unaltered by the world around it, studying and analyzing its history may just take us back to the baby days of our solar system. The secret seems to lie in its primordial craters. Prabal Saxena from NASA's Goddard Flight Center believes that if decoded, these craters can reveal mysteries of the early solar system. Some theories, as mentioned before, suggest the moon was struck by asteroids nearly 4 billion years ago. If proven true, these samples could unlock the secrets of the solar system's birth. What lies beneath the moon's surface might just change our understanding of the cosmos. Imagine a time when the Earth was constantly under siege, a period when the outer planets were intriguingly closer to the Sun than they are now. Such proximity would have been catastrophic for any water on our planet's surface, obliterating any chance of life's existence. However, in a twist of fate, the moon stands as a silent guardian of the Sun's early secrets. Recent studies led by Saxena reveal that the moon has been a silent witness to the Sun's history. In the initial billion years of the Sun's life, its rotation was mysteriously slower by 50% compared to its peers. This peculiar behavior is tied to the unique chemistry of the lunar crust. While Earth and the moon share many elements, the moon surprisingly has significantly less salt and potassium. Using this, Saxena and team crafted models which show the interplay between solar activity and the deposition or removal of these minerals on the moon. Linking the dots between solar flares, star rotation speeds, and the elements present on the moon, they concluded that the sun's slow rotation was responsible for the existing potassium and sodium concentrations on the moon. This information isn't only isolated to the relationship between the moon and the sun. Astonishingly, it also sheds light on why Venus lost its water so swiftly and why Mars's atmosphere disappeared. Earth's atmosphere, too, was shaped by these celestial tales. As NASA and other space giants lay the foundation for a human colony on the moon, a veil of mystery still hangs. Despite our advanced knowledge of the moon, many enigmatic questions linger. One such question that came about as a result of a recent mysterious discovery has left scientists baffled. Deep beneath the south pole of the moon, hidden behind the South Pole Aitken Spa Basin, the largest impact crater in the solar system, something massive lurks. No one is quite sure what it is, but its sheer size could be influencing the moon's gravitational pull. Some believe it could be a piece of heavy metal from an ancient projectile that once struck the moon's surface. Yet the riddle deepens. If the moon's interior is still somewhat active, why hasn't the heat caused this giant object to move? Its current state is reminiscent of Han Solo, frozen and motionless in carbonite. With all the advanced technology and knowledge at our disposal, the only definite thing scientists can confirm is the astounding weight of this enigmatic blob, a whopping 2.4 quadrillion tons. As we delve deeper into the mysteries of our universe, this recent find only adds more questions. What exactly is this massive object? Why is it there? For now, the answers remain buried beneath the moon's icy surface. Preliminary readings hint at unusual energy emissions, a pattern that's inconsistent with any known materials. Researchers and experts from all over the world are rallying together, pooling their expertise and resources in a bid to decipher the blob's secrets. Thank you for being with us. Make sure to watch the next video on your screen. It's amazing.